In this module, we're going to talk about mass timber systems, and we're going to cover it with quite a wide brush, a swath through it. We're only working on one module, and uh, obviously just a brief introduction to it and the performance characteristics of these materials. And played out in labs, it's a little bit different than you might expect. I've created two projects. The primary project is this one where we have this heavy timber frame that creates kind of an arched wing-like structure. Um, and then we take these components out, and it's not illustrated here, but lay them flat so we can get fabrication drawings off of them. So we have a lot of different things that we can learn in this project. But if you're more attuned with this idea of creating a form and panelizing it, and then applying, in this case, curved wood elements, this is your other alternative project. And this project isn't without precedence. I've hyperlinked this so you can review this project. Really beautiful and magnificent for the Swatch headquarters. And we will get another chance to look at mass timber systems when we do a modular project where we're creating unit modules for a multifamily or multi-user commercial building. And in this case, we'll use heavy timber vertical elements in floor systems or ceiling systems. So on the idea of, let me go back to this slide here, the idea of a heavy timber arch system, a good precedence for that is this project here. I hope it's hyperlinked. And it's like a covering for a stadium. And I'm not exactly sure how I managed to find this one. It's in Dutch, so I can translate it to English hopefully here. And but obviously the things, so that's there for you to view. But specifically on the techniques here, what I think are noteworthy are the combination of wood systems with these metal trims on them to form attachment points for what is a skin. This could be a printed ETFE. In this case, it looks like a fabric, Teflon-coated fiberglass fabric, supplied by a company like Bird Air. You notice the shapes, how they're collecting water. So there's a lot of interesting ideas here that could be combined with the project we're working on this week. And this is just another view of that. And obviously there's a little bit of a problem in this rendering where the grain of this wood is just massive compared to the massive element that this is. This should be a very fine grain kind of representation. So, and we're not limited to just modern form, but I think this is just a really beautiful play out of that same idea of a mass timber structural element repeated, now creating a roof system, very much I guess a Japanese influence kind of pagoda-like feeling. I'm not sure I have this hyperlinked. Looks like I do, so we can connect to that and research it if you're interested. And the other one, once again, this kind of modular arrangement of components. This is a distillery. I don't think I have any other images, and it's probably hyperlinked. I'm just verifying that. So you go back and look at all of the detailed images of the construction of this. But I found, what was to me very interesting was the integration of the steel support structures intermingled with the wooden panelized system for this one. And this is a store interior. And I was really captivated by this idea of the columns being actually trees, and whether, and obviously that brings up the issue of how they could structurally perform, how they would be rated in that. And that took me to quite an interesting site here. It's Whole Trees. And so I'm going to click on this and just quickly go to this website because I find it quite fascinating. The idea is that you can, they can pre-analyze naturally occurring wooden structural components that will meet, the requirements of your structure. So if we looked at beams and columns, Here we have all kinds of natural forms, and I believe they have even like charts where you can pick out certain kinds of shapes. And you probably have to be flexible about which way you or what you ultimately expect as far as there be a natural variation in all of these. And some of these look like they actually may now be, well, no, I don't know exactly what's going on there. So this is available for you to review. It's hyperlinked. And a lot of this is highly engineered designs, and I thought this was a really good. This is in this case bamboo, but the obviously a magnificent and complex structure created from bamboo. Humbling for anybody who thinks that we're only in the realm of today of making advanced structures using computers. This looks like this could have been built at any time. Lots of craftsmanship going on here. A pavilion made with wood. I pulled this one out because of the interest of the idea of the connector systems. And once again, we have wood and fabric, and they seem to work really well together. The only thing I find a little bit disturbing about this project is the kind of the overpowering feeling of the attachment or clip systems between the wood elements. And I'm not sure how that could have been, worked through better. In this case, these by putting the plates on the outside, they really dominate the visual appearance. But then they have these connectors here where they have the plates on the inside, and it seems much more visually pleasant. More exposure of wood, and still plenty of exposure of metal. And this is just beautiful renderings of this structure that they had done, and it looks like they constructed it very accurately to the original drawings. So that idea of, sorry, I just zipped forward very fast. This idea of connections with wood, with mass timber system, played out to its maybe its most beautiful examples. Once again, I hyperlink to this architecture firm's really beautiful articulation of connections, almost like Tinker Toy or pinned toy-like architectural elements, but very nice. So that does or does not have to be mass timber, but really specifically now we're going to talk about this idea of mass timber systems, and it's really being heavily exploited right now and very popular on many campuses, many college campuses. Architectural students and the faculty are experimenting with all kinds of new ways of fabricating wood, and in this case, the idea of wood products labs and high performance machines like robotic milling and machining tools. So with all that excitement, we're really reaching not for the stars but for the skies with these very tall wooden structures that have really just come into popular application within the last 10 years. So here we have one that's 18 stories high. It's in Vancouver. One of the and you can actually look off into the distance and kind of get this connection. British Columbia, Vancouver, that whole area of Canada is really a heavily forested area, so there's plenty of wood timber resources for these constructions, and there's a lot of push by government and industry to utilize these resources. And I think it's up to us as architects to determine if those are also the most environmentally positive ways that we can build and create new architecture. And the answer to that may be yes, but I'm kind of leaving that up to a larger discussion. So with this idea of high rises, these are some nice details that I was able to pull off of some of these drawings, just to give you an idea of what, when we talk about mass timber, the serious nature of the amount of mass that's involved in them. So you see these really heavy structural columns, you see these really heavy floor systems, and I've highlighted this one area with a red circle just to indicate just some of the issues that go along with this. If you want to have the ceiling exposed, you actually have to start thinking and accommodating where all of your utility systems are going to go. So you can draw this, but in reality, you have to deal with all these components. So there's one primary consideration with this idea of a mass floor system, as opposed to a joist or open floor span truss system, where you can pass other elements through it, and then you cover the whole thing with drywall to hide it. In this case, you want to see the exposed wood, and it creates another level of complexity, so to speak. The other issue that comes readily apparent is the need to soundproof between these floors. The transmission of sound is a significant issue, and one of the ways they deal with that is by pouring concrete over the slab systems. And the concrete has a heavy carbon footprint, so be wary of the idea of thinking that you're just building in wood when you're using some of these mass timber systems, because of the requirement for dealing with sound transmission, and many times the need to pour concrete floors in order to mitigate that problem. But these are also some really nice building details at the same time, and an idea of the buildup of componentry when you're using wood. And here's a nice detail model of a wood interior, mass system, and exterior. And there's a certain feeling of the elegance or beauty of the simplicity of the wood forms that are happening here. And here we have it in more reality, so to speak. So this looks like the circle's moved off slightly here, but I pointed out a couple of things that are going on here. So we have a mass timber system, really heavy column systems. I believe this undercutting is happening because they're going to pour a concrete floor on top of it. And on top of that, what I find interesting is this other, on top of this layup of a laminated floor system, we've already applied a sheet of plywood or OSB board prior to pouring the concrete. So there's a lot of wood that would normally be in a regular construction system, in addition to all of the mass systems that are with that. And where I'm going with that is that we seem to be using a great deal of wood in these construction systems. Here's a great image of a large slab going in, and you'll notice that it's notched. It's actually spanning over a beam system, but it's a continuous element. It's probably done this way because it's convenient, or simplifies fabrication and removes field joints between the spaces, and allows these two, because they're continuous, to perform better under load. And here we have it in the factory being fabricated. So here we have the laminated, these could be nail or glue laminated together, mass timber systems. They're not thin. This looks like it is at least 8 inches in depth, or maybe more. And then on top of it, the builder is laminating or nailing down a piece of oriented strand board to it. And here's another view of that, probably beginning prepared to be shipped out. And you'll notice the kind of they're all labeled. Each one is for a unique location on the building. And here we have just a nice view of this type of project being erected. It looks like the first floor may be concrete or other materials. I think somebody modified this image just to highlight the wood construction. But a good overview of a system going up in wood. And I pulled this detail probably just to give you a little bit of a feeling for, you can now see that, the orange paint on the labeled panels that we're going in. You can see how they're halfway onto the span of the supporting beam. And you can see these little clips, these little metal clips that are receivers for other clips that are probably embedded in the beams in this assembly. And a lot of that goes to helping make the frame a little bit more rigid. Also interesting to notice this idea of the continuous nature of the columns in order to create probably a little bit more lateral stability, especially during the erection of the building. So we're all pretty well aware that wood can have really great performance properties because of the fact that it will char out and insulate the other wood elements. So we really don't have many concerns about using wood in structures when we're replacing steel and concrete. The only, I guess, thought to be carried through with this, and I might mention this later on, is the wood is a fuel source, so it's also contributing to fire. So if you're exposing the wood in the structure, um, as opposed to steel and or concrete construction, you've introduced a fuel source into the building. So the building will stay up for a long time, but it will also be contributing to the fuel of the fire. Here we have that same building now. We're panelizing it. I thought this was a really great image of the kind of unit module, pre-constructed wall system going into place. You can see the retaining clips. You can see how they've edge banded the wood in order to create some kind of a receiver, possibly for the exterior cladding system. And also notable is the idea that we have a concrete, usually podium or story construction. It's not uncommon in this construction to have a rigid, stiff first floor and then softer floors above that. And to actually, I believe it is to enhance seismic performance of the building. So here we have that building now, stepping back from it to give you a better view of it. And it was, it's a nice time to note how we're getting our shear or lateral stability in our building with our two elevator cores going up through the building. So this is probably what the site looked like prior to any wood framing going up. And then we have now that nestled in to our wood construction. This gentleman is testing the moisture content, I believe, of the wood, making sure that it is at the proper level for use. But what's also really neat to see about this is these steel connection systems between the columns. So here we have, it looks like we can see adhesive or glue blowing out of these, and I'm really not sure. I can't imagine a wood glue being used for any kind of steel support there, so I'm not exactly sure what's going on. But these are probably going deep. This is probably a mating pin that's going deep into this assembly. And these are probably not going into the wood because they're very close to the edge, but they're there to connect to the other column flange that's going to go there. And so here we have a side view of that column, that metal piece. And it looks like from this drawing, we don't see that actually extending into the wood at all. So I'm a little bit curious as to how structurally these two are mated together. But you can see how we have the plate and then the cylindrical piece, and we have one small cylindrical shape and one large cylindrical shape. So they mate with each other as they're being erected. And then you get another feeling for this idea of mass timber systems and what goes into, in this case, fire protecting them, maybe from a fuel source, but also insulating for sound. So we have a really heavy column. And this is where some issues come up about how much space is taken up by these mass timber systems compared with conventional fabrication. So we have up here, we have a large column, and then we have to double frame a wall here. That gives us great isolation between the units, but it also takes up at least what looks like a foot of space instead of 6 inches of space. Why they're triple laminating this, except for a very high fire resistant wall, I'm not exactly sure. We can see now that we have the floor slab, the wood mass timber floor slab, a concrete cap on that, and then it looks like probably finished flooring on top of that. And down here we have, it looks like they've applied a layer of gypsum board, probably for fire resistance. And then they have a channel, which is a noise isolation channel, to suspend 2 other layers of drywall. So there's a lot going on in this construction detail, and a lot of materials are being used. So here we have that, that pin connection. We can see the bolts here. It's not really illustrated. Those bolts aren't showing up in here. And it just happens to be probably by the way they cut through this, because those bolts would either be cut off or behind this flange at the back corners. But you can see them playing through the whole assembly here. Now I guess the only reason I'm highlighting this is just really to indicate that idea of that first floor being a poured concrete podium. And another cross section now of that building. You can see that this is white. This is probably indicated as being full of insulation. No mass timber here at all, just to create a really high R value for the building. I guess that's enough said about that image. And just another nice, these are really attractive renderings and views of the building, and really descriptive. So that's mass timber. I wanted to give you just a couple of other images of things that I think are really beautiful. When we start to work with lumber and we have wood, we can really play up its natural properties, keep it exposed. We can do a lot with the fabrication of curved elements that are relatively inexpensive, excuse me, and able to be fabricated locally. In this case, a curved beam, a laminated curved beam. One of the notable things about this one is we have a mass timber spanning a large area. And in order to give it extra strength, they put these struts on and then cable tension this. So now we have basically an inverted bow truss with the the steel working in tension here. But that's not the and obviously this has a nice undulation to it and a nice front end undulation with it also. Here we have really massive. These are laminated columns with obviously really high bearing capacities. I'll show you in another slide here the beautiful connections of these columns. It's interesting to note these wings that are coming off of here that are actually are being utilized to help stabilize the glass curtain wall, giving a great sense of transparency to the whole space. So here's a nice detail of that connection, a cast element. All of these ideas are really at our disposal as designers while we're coming up with things. So here's still another kind of cast connection between the wood element and some kind of tie back to the structural element, pinned connections, and a really beautifully detailed series of all kinds of connection details. And this was obviously, to me, this is a really beautiful connection detail. I don't know where this is, whether it's actually on that building there. And now we have all of these pieces of timber coming in with different widths to them, and then expressed into the metal to the connection, to the pin connection to the center point. And a lot of that, like this, looks like paralam material, where we have wood chips that are laminated one on top of the other to create these kind of large, thick structures. So paralam, all of the grain is running in the direction, like the normal grain direction, as opposed to our oriented strand board, where there's a lot more variation in it. You're still oriented in it. They try to orient them in a perpendicular way, but these are now, the grains are really tracking very carefully with each other and delivering a really high performance product. I keep this in here because this is fascinating. I stumbled on this while I was doing a lot of research for this. I found this building to be, this idea of this tip way out here in space, carrying a snow load, resisting a wind load, to be really quite amazing looking. And I was able to actually find it under construction, doing a little bit of research. And I think because these are actually almost exactly the same image angle, I was able to kind of like place one over the other. And this is not really a hugely successful attempt at that, but it really does show you, if we go back and look at the structure here, how we get to these very thin looking exterior end conditions of roof systems. So we have these massive truss systems coming out this one coming off of even like a concrete wall, a massive truss tapering down to zero because the loads are going down to almost virtually nil at the end of the assembly. And then beyond that, the outriggers, even the final outrigger going down to tapering to just a very thin edge in order to create that sense of elegance to that final roof edge. And I think that's really compelling. Obviously, if this was a much thicker looking element, it would kind of detract from the illusion of its lightness and almost defying structural possibilities. So that was my distraction on that. Back to heavy timber and this idea of connectors is always on my mind. I think this is the place where many times in the application they try to not show the connectors, and the reason for that is that they're protecting them from fire. But I find this in this case, because the building had to be sprinklered for whatever reason, it might be a secondary reason, it might have been a primary reason. They they don't need to protect these from failure in a fire because they've got a protection system for that. At least that's my theory on that. And I think the connectors become a very interesting element. They help the viewer understand the way the loads are carried and distributed in the structure. These aren't the most beautiful, but I find these to be more interesting than these things dying into something with the fastener hidden, almost defying the idea that they could be actually carrying the loads. So one of the things I thought about with this, though, is I looked at some of these details and I was wondering why these bolt systems were the way they were. And I think one of the reasons is that these laminated timbers will shrink. And by providing too many, in this case, the weight of this beam is being carried on the bottom plate here. And if we were to put a series of holes through all of these at various locations rigidly, through any shrinkage or any changes of the depth of this beam, it would be likely that one of these bolts would cause the kind of stresses that might actually fracture or split this beam. So I'm believing that's why that was inserted in that assembly, or that bolt condition is the way it is. So we've done adaptive columns that come out and distribute loads like this. So really, I think a nice way to deal with distributing these loads or carrying these loads back down to center column systems. And then once again, all of these I guess transfers from wood to steel of load path all become architectural elements in and of themselves. And once again, they're exposed, and they're probably exposed because it looks like we may also have a sprinkler system here, although these also could be drained, I'm not sure. So when I showed you these exposed fasteners, the compare and contrast is actually these kind of connection systems where we have a piece of wood dying perfectly into another piece of wood, and even this gap here, so it's not like one is inside of the other. And that really defies the logic. What's holding that piece of lumber into that? And I find it to be very troublesome. A lot of people probably don't give it a second thought and actually find this to be a more attractive look to the connection. But when we look back on some of these earlier projects where we were really articulating what was happening here, there's just not enough visible for the viewer to understand how loads are being transferred. And that's because we have all of this happening on the inside. We have these welded plates with elements diving way deeper into the lumber in order to transfer loads. So we're always playing between that idea of no fasteners and then really articulated fasteners. And this one, obviously, these are probably for some kind of a shear load control or shear performance in a wall system or a structural system. And then I thought this is just a really cool looking kind of detail. It looks like it has a cast center component in it. The idea of fastening this is kind of this is a lot of time spent in the literature on this, but the idea that when we're working between things that are natural like wood and things that are man-made like concrete and steel, um, we have the natural behaviors of wood to expand and contract. Not that steel won't do the same, but the real problem with wood is that you introduce stresses at connector systems that can lead to failure of those joints. And in steel, we deal with it a bit differently. Most of the time when we're using steel, it's always steel to steel, so everything is expanding and contracting at the same rate. So, but anyway, one of the things you should start paying attention to when you look at the connector systems is the idea of slotting, of allowing for the natural changes according to moisture and natural expansion of the materials to not be destructive of their connection systems. And so that completes the introduction to mass timber and wood.